Velkommen til NUUG og ISOC Norges felles medlemsmøte. We'll take it from English from here because our speaker is from abroad. Welcome to the Norwegian Unix User Group of and the Internet Society of Norway. A joint meeting with a presentation from our Massimiliano Stucchi, who actually works for the international part of the Internet Society. Take it away, Max.
Hello, good evening, everyone. Yes, I work at the Internet Society. I'm originally from Italy, but now I live in Switzerland, not in Geneva, as you might think. That's where some of my colleagues are. There's a bunch of colleagues. There's an office in Geneva, but I don't live there. I live in Zurich. And today we've had weather that resembles the weather you have in Norway. I was talking to Peter a moment ago, and looks like we have same kind of snow here and up there in Norway. And then today I'm also celebrating by having a mug from Oslo for the tea I will be taking while presenting to you about MANRS. As I said, I work at the Internet Society. My position is as a technical expert for the for Europe. But mostly I work on community networks. Most of my time is devoted to the Community Networks project, which is something different from MANRS at the Internet Society. And but there I am the project lead. I lead the project for people who want to set up their own community networks, while also participating in the MANRS project. And that's why I'm here, because also some of you might know that in the past, I've also done some tutorials and other presentations together with Peter. So we got in touch and discussed about this presentation some time ago. So before we start, we need to discuss about the problem we're trying to solve here. MANRS is an initiative that tries to help internet routing in getting more and more secure by asking participants to do something. And we'll see these actions in a moment. But before we go into this, what problems are we trying to solve? We have incidents on the internet. These happen pretty much every day. Because if you look at the numbers, these are numbers for 2018. The numbers for 2019 and 2020 are very, very similar. But imagine you have 12,000 incidents, outages or attacks, route leaks and hijacks. Imagine having almost 5% of all the autonomous systems on the internet affected by these issues. And imagine having, if you look at these numbers, 2,700 autonomous systems being victims of at least a routing incident. And then a small number of these networks, 1,200, were responsible for 4,000 routing incidents. So we've had many of these across the years. These are nothing new, but some years ago, some people decided to start doing something about it. And MANRS is trying to solve these issues. Prefix and route hijacking, which means a network that tries to step over the announcements on the internet from another network to attract traffic, to take over some of the traffic that should go to the affected network, and maybe be part of a larger scheme where there is some attack being portrayed in this case. There are some examples of people who have redirected traffic that was supposed to go to AWS. The traffic was redirected to another destination. The destination had services set up such as DNS, such as web services that resembled the ones for AWS. They were hosting to understand that it wasn't a hijack. The website was fine. The address was the one that was supposed to be. Nothing could let you understand that this was a hijack happening. But then people logged into the service, provided username and password to these attackers. The attackers went and used their logins to log into the real service, and they stole money from some accounts. And in a very small amount of time, they were able to steal about, I think, $100,000 without people noticing, because everything seemed legitimate. This is the prefix and route hijacking, but then we have route leaks, where a misconfigured router on the internet, because it's configured without putting any protection, without setting any limits for BGP sessions, propagates information to other routers and creates issues for the rest of the internet. There was one a couple of days ago that was reported. I'll paste the link later for you to see, but that's the route leaks are more serious than you can think. They happen even more often than you can think, and they represent one of the biggest issues we have nowadays. And then we have IP address spoofing. This is a little bit harder to make, but still you pretend to have another IP address. You send a communication. Normally you use UDP for that, and you pretend to be someone else. The network you're connected to doesn't perform any checks on the source addresses, just propagates its routes, but also forwards the packet, even if the source is not inside its network. Routes the packet hits a server, the reply goes to the address that's being spoofed. And this can be used in larger schemes to play denial of services or distributed denial of service. So these are the big three groups of issues we're looking at now for routing security, and network operators are in this together. It takes a collaborative effort to fix all these issues, because I could be fixing my network, but then, as I said, somebody else might not configure their filters or their routers properly, and then that is going to affect my network. So what we're doing here is taking normal routing, taking BGP, taking all these protocols, and adding pieces on top of them to enhance their robustness, enhance the security of the whole internet. But as I said, this is a collaborative effort where pretty much everyone should collaborate to make the internet a better place. And so here comes MANRS. It stands for Mutually Agreed Norms for Routing Security. And what it does is basically define actions and say, if you want to improve the security, here are some operational practices that you should be following to improve your situation. And then you can become part of this, of the community. You can be part of the MANRS community. We publish the names of the ISPs and the IXPs and that participate, that have told us they implemented MANRS. There are some checks that are made to make sure that the actions have been taken seriously. And here there are and once you implement all these actions, your routing gets more secure, your network is well behaved on the internet. So what are these big actions? There are 4 actions in the main MANRS document, MANRS for network operators. We'll see in a moment that there are also other recommendations. The first one is coordination. So what does it mean? It means maintaining a globally accessible series of contacts. For this, we have the RIPE database. That's a facility you should be using to implement this first action. Publish the information about how you can be reached if there's an issue, your NOC, how they can be reached, abuse contacts, and all these details. That's the reason why the RIPE database was created initially. It was so that people could get in touch with other network operators via phone, email, if there was an issue. And this is where you have your first point of contact. So you see like a route leak coming from an operator, you should be able to go on the RIPE database or the database of the regional internet registry of the region the other operator is from. Check it, find an email address, find maybe a phone number you can use to get in touch with the other operator and try to fix the issue together. Then we have validation. Validation means check that this data is properly assessed. So make sure that what you find in the database, because not only you have contact data, but you also have routing information. So you probably would know about route objects. When you look at route objects, you want to validate what's in there, what the information contained there is, make sure that it represents what you see in the routing table. And this is the second action. Then we have anti-spoofing. Anti-spoofing is where we make sure that from our network, only packets that are supposed to be originated in our network come from. So we validate the source address of every packet that's being originated from our network. And then you have filtering as last, where you also use the data in coordination and global validation to build filters to secure your perimeter and secure your routing sessions. Make sure you don't accept or propagate incorrect information from the routing table. Then we have MANRS that are also for IXPs. So we add, there are some additional actions that's about promoting MANRS to the membership that have been added. There's a MANRS for IXPs. There's MANRS for CDNs and cloud. So we have an ever growing number of documents. Again, there's one action that's about encouraging the adoption, but also the biggest part for a CDN is to make sure that they're not propagating incorrect routing information. The features of a CDN is that the CDN normally spans all the continents, has a big number of BGP sessions as close as possible to the end users they're trying to reach. So if a CDN starts propagating incorrect routing information, that's going to have a global effect, because the CDNs peer with a very, very large number of other networks. They are directly connected, and the propagation would happen very, very quickly. So at that point, you would have a real issue that's propagated globally in a glimpse. So in this case, the MANRS for CDN and cloud make sure that there's a big stance on trying to push the CDNs to not propagate incorrect information. There is another document called the MANRS for vendors that's probably happening soon, but it's still being worked on, and the details are still being looked at. So I can't tell you anything about it because there's nothing yet concrete, but it's hopefully in the works for 2021. Now, MANRS has a broad document that define high level these 4 actions, but then there's the implementation guide, and the implementation guide goes into greater details about what needs to be done to implement MANRS in your network. So this is a best current operational practice that's based on other best current operational practices, and it's also published as a RIPE document. I'm not sure the one from 25th of January is the last one. I'm not sure 1.0 is the last one, the one you see a screenshot here, but we can check later. And I know there are changes coming to the document also in 2021. Things are planned. So you're very welcome to have a look, but there could be more than what you will see here. So how many operators have adopted MANRS? We're talking more than 500 ISPs and more than 40 Internet exchange points, which represents so far a big win for the movement. Of course, there are 65,000 ASNs, autonomous system networks out there, but we will get there. Hopefully MANRS will become more and more adopted. So we'll see about this. So one step is to start presenting, as I'm doing, and try to get more and more people to know about MANRS and get more people involved in implementing it in their networks. So, sorry, looking at more details. Give me 1 second. We have. Let's go into more details about the coordination and global validation. So how does this work? Data needs to be published in the regional databases. In this case, I'm speaking to you in Norway. Norway is part of the same region where I am, part of the RIPE region. As a spoiler, I used to work before I joined the Internet Society in 2019. I used to work at RIPE NCC, so I used to actually give training courses about how to put data into the RIPE database. And so we'll go into more details about that. There is a PeeringDB. PeeringDB is important because it gives, it's a database that contains facilities, so data centers. It contains Internet exchange points. And if you operate a network, you can fill in information about which Internet exchange you're connected to, what is your IP address there, what peering policy you have as a network, if it's an open peering policy or not. And then you can find easily information about other networks that are peering at the same Internet exchanges. And you can use it as a source of data to also figure out, like, if you want to join a new Internet exchange, who will I find there? How is this going to affect my routing? Is this going to affect it positively, in the sense that I'm going to find new networks that I'm not peering with yet? Or is it just the same type of networks I already have at my own local Internet exchange? So PeeringDB is a very useful area of information because it tells you where other networks are, where you could peer with them, and it also gives you a couple of other small information that you don't find in the regional databases, and I'll get to that in a moment. Last, you find also data in the Internet Routing Registry, which is the small part of the regional registry database. In the RIPE region, it's one big database, but in other regions, they are separate. And so there you find, when we talk about IRR data, we talk about root objects, root 6 objects, the objects that define if you are an autonomous system, what networks you're supposed to be announcing, and then we have the RPKI data. So going into more details, if you operate a network and you are in the RIPE region, you want to have data like a maintainer, a person object, and a role object for your NOC or team. And all of these need to be referenced in the organization object, which is a bigger object that's created actually by the RIPE NCC with the data you provided them about your organization. And then the INET Nums or the INET 6 Nums for your allocations. What are these objects? Maintainer is for security. Maintainer contains the way to authenticate who can modify other objects, who can create other objects. So that is the first one you need. But together with it, you need a person object. And I suggest everyone who operates a network to have his or her own person object with a little bit of data on how to reach yourself. And then once you have a small team, you can create a role object. A role object is an object that groups persons all together in a team. So you can only post one link to an object, and then that references all of the team participants in one go. And then INET Nums and INET 6 Nums are objects that represent a network. So INET Nums are for IPv4, INET 6 Nums, as the name suggests, are for IPv6. So the role object can have two different meanings, and it's used for two different, it's the same goal, but done in a slightly different way. So you can put together a group of person objects, but also you can use it to publish your abuse contact. And then there's an attribute that's called an attribute called the abuse mailbox, that where you put an email address there and you say, if you have any abuse information, send it to this email address. So this serves for other networks to have a way to quickly find how to provide you with information about what's going on in your network. If there's any abuse coming from your network, you want to know about it because you want to make sure you understand about it, and you probably want to stop it. You want to maybe talk to your users, make sure they don't do it anymore, but you need to know about it and you want other networks to contact you about it. So that's for the abuse mailbox. And this actually requires a little bit of a more complicated stand here, because there is the role you have to create, the role object you create has its own nick handle, which is a unique identifier. And then in there, you reference the abuse mailbox, which says, in this case, report it at example.com. But then this role object needs to be referenced by another object using the abuse-c attribute, and says, look into that role object to find the abuse mailbox. So this in the RIPE database creates a relationship where the RIPE database will show you directly the abuse mailbox when looking up abuse contacts for a certain network. And then the role object helps you also put together more person objects where you have, especially when you have multiple networks you take care of. You see on the right we have all those IP blocks. Imagine we have one network operator that is Jean Bleu. It's easy to manage all this when you reference Jean Bleu in the role, and you say the administrator contact and the technical contact is Jean Bleu, and this affects all the objects in the IP block. You see, so when Jean Bleu you want to change it, or Jean Bleu moves to another operator, you just have to remove him or her, and then all the objects will be updated with the new person, Betty White, who joined the organization. Otherwise, if you don't use a role object, you would have to go and change this contact information in every single IP block you find. And that might be a long job or something you might want to automate, but still you would need to write a script, make sure you know about the APIs for the RIPE database, provide the exact authentication, this and that. If you instead use a role object, you just have to change 2 lines in the file and you're done, and you don't have to do anything. Then here is the difference between IPv4, the INET Nums, and the INET 6 Nums. As you can see, there is actually no difference other than the status. The status has been changed. There are different statuses for an INET 6 num that are slightly different from the ones you see for the INET nums. And on top of that, there's another thing. The INET nums represent a range, so they can be 1 address, they can be 2, 3, 4, 5. They can represent the whole internet. Actually, if you check the RIPE database, the structure of the database, the way it's created, it actually does have an object that represents 0/0, because that's a root of everything. And then below it, there are all the other objects that represent all the network delegations that are shown in the database. And then we have in the, so the IPv4, the INET num represents a range and can be anything. It doesn't have to be aligned with the with networks, with CIDR, doesn't have to do that. While the INET 6 num, because of the different nature of IPv6, does need to have the / notation. So you need to always have, in this case, you see there's 2001 DB8 /32, and in INET 6 in the INET 6 num, you always go up all the way to /64. That's the smallest object you should see in the database. If there's anything smaller than a /64, then there's a problem, because you shouldn't be representing that. So how do you do things in PeeringDB instead? You register an account, you associate it with your ASN and organization, and all the information you can, especially, and here we get back to what I meant earlier, you add the contacts. So you add the contacts of your peering manager, phone numbers, working hours, if the peering manager only works during office hours or is reachable 24/7, but also, and here is a point, the AS set. We'll get to the AS set in a moment, but mind you, the AS set is something that is in the RIPE database, but could be in any other database. And there's more than 30 of those. And in PeeringDB, you find how to associate that with the AS number you're talking to. We'll get to that in a moment. I'll give you more information about this in a moment. You also find IXPs, exchange points, the facilities where you peer or have a POP. So PeeringDB has an API, and there are many, many tools that exist to leverage this API. So it helps you deciding where to peer. So it gives you a list of the peers at an IXP, but also all the other networks that are present in a facility. So you can also understand if I want to go and reach a certain facility, who can I buy transport from, or who will help me reach that? And it helps you in general make your life easier, because then you have a way to more quickly find the direct contacts for a network. And the power of PeeringDB is that you need to be logged in to see personal records and information about peering managers for other networks. So it's only for people who are involved in peering. So the data is not seen publicly. So you're free to put more data about how to reach you, because that data doesn't get dispersed to everyone. So here we're having a final part about routes and Route 6 objects, which are used to create BGP filters, and this will all get together later. So I have entries in the RIPE database that tell me this IPv4 or IPv6 prefix should be originated by this AS number. So if I do a query the other way around and I ask the database, tell me all the prefixes that should be being originated by this AS number, then I can build a list. And from there, I can build my prefix lists that go into my routers. And there are tools to do this. So the IPv6 routes and IPv4 routes are objects that tell me this INET 6num, or this network, should be announced by this ASN that's in the origin attribute in my route object. And as you can see, the IPv4 INET nums and route objects are exactly the same to the IPv6 ones. But then let's going a little bit more complex. I told you we have AS sets, but what are AS sets? AS sets are a way for me to figure out the customer cone of a certain autonomous system. So in this case, I used an example from a friend. There's an AS set from AS15562, column AS Snyders, and in there I have different members, which tells me if you are peering with this ASN 15562, you need to consider that this ASN will be announcing to you all the networks from these customers, these members. And then a member could be another AS set that has other AS sets inside. And then there's a list of all the origin autonomous systems that I should be keeping track of. So when I want to build a prefix list connecting to such a network, I would need to build it by cycling through all the entries in the members of this AS set and checking all the routes they are supposed to be originating. Now, the limitations of the AS sets are that there are about 30 databases, not only the RIPE database where they could be stored, and some of them they could have the same name but be on different databases and have different entries inside as members. So we need to keep this in mind, and we need to find another way to assess, to figure out which AS set I need to use in my filtering. So in this case, we can use PeeringDB, and that's an important feature to figure out which database I have to look into and exactly what's the name of the AS set I would need to look at. Because, for example, I have my own autonomous system number, but my AS set is called AS-Stucky, which is my surname for fun. But someone else could create another AS-Stucky AS set in some other database, and they could put other information in there. So it's a place where we're now trying, as global community, especially as the ITF, to put a little bit more clear view with RPKI, and we'll see that in a moment. So this was the part about the database. We publish information. We publish information about how to reach us, and we publish information about what you are supposed to see coming from us in terms of networks. Now, anti-spoofing is another part we have to look at, and it's a system that's supposed to help me as a network operator make sure that I am not forwarding packets that should be coming from another network, that have a source address that's not an address of mine. So what RPF does, that is the tool that we use here, is check generally if an entry exists in the routing table before accepting the packet and forwarding it. And we have 4 modes of operation here. So these 4 modes of operation have been defined in an RFC, and then I'll get into a little bit more details. There is loose RPF that says it checks. So as I'm a router, I receive a packet. If I have RPF enabled on my interface, I check that the entry exists in the routing table for the network that I see as source address on that packet. Now, when you think about loose RPF, we're not doing much in terms of checks. As long as the network exists, I'm fine. I will forward it. So only if I have very, very, very strict policies to filter at my edges, at the edges of my network, this will become effective. And only if someone is using a bogon address as source, or networks that are not announced on the internet. So this is the mode that you don't really want to use. So I used to recommend using loose mode on the interfaces facing other operators, so at the edge. I wouldn't recommend it now, but I would recommend instead using strict RPF on the interfaces that enabling it on the interfaces that face your customers. Why? Because in strict mode, you check that an entry exists in the routing table, and you make sure that this route you find points to the same interface you received the packet from. So what you're saying is basically, if I know who you are and where you're supposed to come from, and the packet comes exactly from that source, then I'm fine. I'm forwarding the packet. Otherwise, I'm just discarding it. Then there is also feasible path RPF mode. That's a little more open and says, I check that the entry exists in the routing table or any other route installed or preferred. So I might have something in my in my routing table that I have not preferred, not installed in my forwarding table, but if it exists, it means there should be a way to reach it. So I use feasible path. And then I have VRF. VRF is the same as strict, but looks into different VRFs. So it's just an extension to strict mode. So what I suggest is to enable RPF in strict mode towards the interfaces you have on the interfaces you have towards your customers. So how do we do it? It's actually relatively simple. I'm giving you 3 examples here. There's Cisco, and as you can see, you pick an interface and you say IP verify unicast source reachable via the receiving interface. You have Juniper. Juniper is even simpler, RPF check. But then You can do the same on FreeBSD, for example, or OpenBSD. And you could ask Peter, but also I put an example here. And basically you say block anything where URPF failed. So anything that comes in from this interface where URPF failed, don't forward it. And then now you can adjust it for your own configuration here. But basically the facility is there, so we can use it also on FreeBSD, on OpenBSD. And of course, there's a way to do it also on Linux. I think how is the firewall called for Linux? Because now there's micro firewall, but anyway, so Linux also has these facilities. You could also use ACLs, basically just filter out by source. And there's an example with Cisco. There's an example with Juniper, basically where you say just don't accept anything where the source address is different from the ones you should find in this network segment. And you can do the same with PF or your favorite packet filter. So that is for RPF, which is relatively simple to configure. But now we look into something that's a little bit more complex. Because when I say filtering here, I mean filtering in BGP. And it's a totally different world from setting up a packet filter. So you want to establish that these are techniques for deciding which routes to allow inside your routing table or your network. And then also what you announce to your neighbors. So why is it important? Because it's your first line of defense. You control what you are announcing, but you have no control over what other networks announce to you. And so you have to decide what to accept from other networks. Now, how do you do this? You use a facility that we have checked a moment ago. You check the routing registry. So you check root objects, but also you could check RPKI. And we'll get to that. You have internet routing registries, you have the bogons list, and then you have PeeringDB for AS sets as your data sources, as your generic data sources. Then you have RPKI. So how do you generate a prefix filter? I mentioned it already. You start from an AS set, then you do a reverse lookup. You say, give me for each one of these members all the route or route 6 objects. That goes through a tool. You do the reverse lookup with it, and then you load these prefixes into your routers. So you first have to check the AS set. So you walk the AS set, prepare a list of all the ASNs it contains, and you recursively walk an AS set if you find it. So you walk, you create a whole tree and a list of all the ASNs you have, and with that list, you do an inverse query for each one saying, tell me all the objects where you see this ASN as an origin. And then you build your list. Now, what are the best practices for doing this? You should not accept bogon ASNs. You should not accept bogon prefixes. Bogons are ASNs or networks that should not be announced over the public internet. And then unless you have a situation where you have split POPs that are not connected directly to each other, you shouldn't accept your own prefix. So that is something you shouldn't be doing. Don't accept the default route unless you requested it. And here we could talk about this for hours. There are some people who advocate about if you don't really need to do multi-homing, to look at multiple routing tables, just accept default from one ISP and then more specifics from another one, or just get a default from one network operator and then connect to an internet exchange for diversity. So get a default from the ISP and then have the more specific networks from the internet exchange. There are different discussions going on. I participate in ITNOG, the Italian Network Operators Group, and there we basically every 2-3 weeks we have this discussion about the flavor of BGP configuration you might want. I'm of the church of let's look into what you find in BGP, because that's where you can also set up more, let's say, protection for yourself. Don't accept anything that is too specific. Here, another suggestion, which means /24, nothing more than a /24 for IPv4, but also the recommendation is nothing more than a /48 for IPv6. Although here, I usually mention an example here for IPv6, and it's, I think in a few years we will decide to move this, to move the bar to be a bit higher than a /48, because, so I told you I have my own ASN, and as such I also have my own /29. Now, I could, from my /29, announce every single separate /48 I have in my /29, which is 500,000, well, more than 500,000. If I create the root objects for them and I announce them, then I would end up in a situation where I'm announcing 500,000 entries in the routing table, and they are perfectly legitimate. And the way I do it, every other ASN or every other operator in the world could do that. So imagine how bloated at that point the routing table for IPv6 would be. So imagine this. And so that's why I think in, well, maybe at a certain point in time, we will agree on moving the bar from /48 maybe to the allocation size, to the minimum allocation size, that's a /32. And then just keep the /48 mark for the networks that are called PI. But they are in a different part of the address space, and so that's something we can control relatively easily. Now, then don't accept anything if the AS path is too long. If the AS path is too long, and we're talking 100, maybe 100 entries in the AS path, because that means there's either a misconfiguration or someone who did something very stupid, or a hijack happening at the moment, where someone injected something that shouldn't be there. And then create filters based on internet routing registries. So how do we do this? We start from the bogons. Routes you shouldn't see in the routing table. So that's private addresses, unallocated address space, and reserved address space. Team Camry provides a list for both v6 and v4, updated daily. So they basically take the list of all the networks that have been allocated in the world and assigned. They reverse it, and they take all the entries and put them in a list. And if you check the link here in the slides, then I'll provide also a PDF version of the slides. If you Google for Team Camry bogons, you'll see that you can get the list daily. Or they also used to provide a BGP stream where you say, you connect to BGP and you get all these entries in a BGP session, and then you can configure your BGP session to route these bogons to a null interface in your network, or a collector somewhere to see what traffic comes in for destinations that are not supposed to be reached. Here's for reference, a list of the bogon ASNs. Some of them are private, some of them are reserved for documentation. Some of them, there's 2, 3, 4, 5, 6 is the one for transition between 16-bit ASNs and 32-bit ASNs. And but now you shouldn't be seeing any of those, any AS23456 on the internet at this time. Then you build prefix lists. Those are the routes you want to accept. You can create them manually or automatically with data from the IRRs. And there are tools. There's BGPQ3, BGPQ4, which is a newer version. There's PEval and the level 3 filter generator. So let me show you. So we have BGPQ4, which is the de facto standard for generating filters. It's written in C and uses the entity routing registry as primary data source. And it can generate filters for Cisco, Juniper, Bird, OpenBGPD, MikroTik, anything. It's very well maintained by Job Snijders. And I can show you an example of how that works from a system of mine. Give me 1 second, because I realized I need to actually go on log into a different server rather than the one I was on. And here I have it. Okay, so let me stop sharing the screen because I'm sharing, share another one. Okay, 1 second. Now the share screen button doesn't really want to work anymore. Oh, there you are. No, now I see it. No, the window was hidden. Okay, 1 second, because I have SSH. So this is the one you want to see. Here we go. Let me make it a bit bigger. So here I'm connected to the router it's actually in the other room at home here. But is the prompt big enough? Peter, can you give me a sign if it's fine? If you can read it. Okay, 1 second. I'm resizing the window because I see that it maintains proportions. There we go. Yeah, that's better for everyone. So here I have BGPQ4, and let's say I have a network. I always use 3333. That's the ASN of RIPE-NCC. And when I run this, it gives me a prefix list that's for Cisco, but I could do Juniper, for example, and I always get confused about which one, there's Bird, there is Juniper, and there is OpenBGPD, for example. So let's go with capital B, -B, AS3333. There we go. So here you go. You will get a prefix list that's prepared exactly for OpenBGPD. We could be, I think B is Bird, and you see that it's quite the same. I could give it a name and call it RIPE-NCC. So in this case, it gets a name, and I can take this, load it into my router, and provide it with more configuration. The same thing, I can do it with, look at the difference. This is an AS set. And look at the difference in size in this prefix list, because the AS set contains more networks that are part of the whole routing for RIPE-NCC. So in this case, I get a lot more networks. If I run a certain, let's try, I'm not sure it works because I don't think let's call it like this and do, let's see if it works. So this is a huge network, network operator from Russia. And this a set contains a whole list of, see, that contains 880,000 entries here. Many of them are small. Some people have put in root objects for /32's IPv4 and so on. But as you can see, you can also have very, very large objects in this database. So it's something that's really, really powerful in a certain way, but you have to make sure you're getting the right data. So here we go. This was the this is BGPQ4, and no, say not now. There we go. And now I would like to share my screen again. Okay, how do I share it? Oh, remove that. Okay. Okay, here we go. So let's go back to the presentation. So the provisioning now needs to be done, and the list should be updated every day, because every day an operator might have gotten a new customer or might have received a new network to use in their configuration. And so you want to automate this to happen every day. And then you can use netcon, for even better, Ansible or Salt. Ansible has modules for pretty much any network device. In the case of Bird or OpenBGPD, you could just use SCP or rsync to, you generate the configurations on another device, on another router, and then you upload them to your edge routers. You can rsync them, and but pay attention to consider all the cases in your procedures. So I know a person who built a whole automation system around the RIPE database. One night, the RIPE database was down for maintenance. So he basically black-holed his entire network, because he built filters using input from a database that was down. So the input he got was empty lists. So he was building prefix lists that were empty, saying, don't let anything through. And he basically black-holed his own network overnight. So don't follow this example. Now, I mentioned that there is an additional thing we can use, that's RPKI, and I'll try to be a bit quick here. RPKI builds on top of what we have in the Internet Routing Registries, but it was meant to provide more facilities to figure out what we have in the routing registry. So what a network is supposed to be announcing. RPKI comes because the routing registries are not secure enough. They sometimes, some of them contain data that is from dubious origins. So if I were to show you BGPQ4, the output for my own ASN, you would see that there are two entries for IPv6, one for a /32, one for a /29. The one for the /32, I didn't create it, but it was created by an operator that was being my transit when I started using my own ASN. And they decided arbitrarily to create an entry, to create a route object, a route 6 object for me in a database called RADB. RADB doesn't provide any authentication for the creation of these objects, as long as you have a user. And for the user, you pay $450 a year. And there is no entry for that address space in any database they mirror. So still hadn't created my root objects in the RIPE database. So RADB gives you the chance to just create whatever you want. If no one else has created anything in that part of the address space before, you just go ahead and do it. So for this reason, this RADB is an example, people started thinking about a better way to create trust on the internet. And here comes RPKI. So in RPKI, you have a chain of trust, you have certificates, you have keys, and you have signatures. Every member of RIPE-NCC gets its own certificate, and then you have signatures that create relationships, a chain of trust between them. So then we have two different parts of RPKI. We have the part where you sign something, so similar to what we did with root objects. We tell the world, this is what my network will be announcing. So you create what's called a ROA. And then totally separate from this, you can be validating what others have published. So a ROA is, as a root origin authorization, it's an object you create in RPKI. You can create multiple ROAs for an IP range. They can all overlap as well, so you can do whatever you want with them. But they contain three key information. One is the prefix, so the network for which you're creating the ROA. The origin ASN, so the ASN that's supposed to be originating the BGP announcement. And last, this is an addition from a route object. You have what's called max length, the maximum prefix length accepted for this ROA. The ROAs get signed. We'll get back to max length in a moment. The ROAs get signed, and then altogether there is a whole relationship between the ROA, the resources from the local internet registry from a member, and then the certificate from RIPE-NCC. So you have a way to verify that the ROA really should be existing and that there's a chain of trust. So we'll get to that. How do you create a ROA? You can do it in two ways. One is called hosted RPKI. So that's where the RIPE-NCC, in our case, manages the whole system. Everything is automated. You have a public interface. You just log in, you create your ROAs, you say, this is what I want, and it gets created, signed, maintained. Everything's done by RIPE-NCC. So that lets you focus on creating and publishing ROAs. And then there's the non-hosted RPKI. So you run your own certificate authority with your own software. At the moment, this is something I wrote a couple of years ago, but still Krill, there is a software called Krill that is almost there. Really, you could use it, it works. But I would say, unless you have specific use cases, I would suggest to not go with the Krill solution. RIPE-NCC has made it really, really simple to use their interface. As you can see, you can just log on. You get all the BGP announcements they see from your ASN, from systems that RIPE-NCC runs across the world. So they tell you, this is the ROA, these are the ROAs you should be creating. And then you have an easy way. So you say, I want to create ROAs for these entries. Just do that. They get staged, and then you can go and review the changes. This is a nice animation, and you can say, okay, publish them, and they got published. And now you have 7 ROAs. And then you can check also that there is a validity, what's valid in your system, what is unknown, and what you have created. And then you could also check if you have any issues. So in here, you see that there's an issue with an invalid length, and you can say, okay, help me fix it. Just create a new ROA that matches or extend the other one. And you can take you can take a decision and say, create another ROA, overlaps with the other one, publish it, and the problem is fixed. So as you could see, we fixed the ROA issue in 5 seconds, and that's how long it takes. Now, how does it work with max length? I'll just also be quick here. So imagine you have a ROA that says 193.0.24.0/21, and it says the origin is AS2121 without specifying a max length. This means that this ROA is only valid for the /21 it represents. So all the other BGP announcements, if you have them, they're not covered by this ROA. They would be called invalids. But you can fix it by creating overlapping ROAs. Let's say this ROA says /23, that's specific /23 with a max length of 24, so it covers any /23, any /24 under that range. And then everything under that cone would be accepted. On the other hand, without specifying a max length, so we only keep the /23 valid in this case. So this should give you an idea of how max length works. Now, there is a draft RFC that mentions how specifying a very permissive max length can be an issue, because I could take your ASN. If I want to hijack your network, I could take your ASN, announce it from behind my network, so add your ASN to my AS set, wait for everyone's filter to update. Then I would originate the networks from your ASN behind my network. Same with a more permissive max length. It would be allowing it for me. So let's say I announce one of those two /24s that are blue in there, while you're only announcing the /23 at the moment. I would be attracting your traffic towards me. RPKI would not say anything, would not tell me there's an issue, would not tell anyone there is an issue, because the originator is still the ASN that's in the ROA. And that would mean you would get a hijack over your network even though you have RPKI. So there's a draft RFC that mentions this specific case and suggests that basically you match in ROAs what you have in root objects. So you'll be as strict as possible. Now, there are repercussions on this, and I can already think some of you might be looking into issues that you could come up with when you instead want to have a DDoS protection, because you want to act fast, you want to have someone else announce your network, so you would want those people to be able to do it. You want to create a ROA that allows them to do so. You can do that, but still you have to pay attention to who announces your network there for real. Now, how does RPKI work? We create the ROAs. The ROAs come from all 5 the regional registries. I need a validator. That's a software that that takes all these ROAs and checks if the chain of trust is okay, and then the validator talks to my router. So in more detail, the validator software does a verification, creates what's called the validated cache, and then there's a protocol called RPKI RTR that talks to my routers and enables them to take routing decisions based on what's in RPKI. So how does this work in more detail? I have my ROA. My ROAs can be either invalid when the chain of trust is not fulfilled. So the certificate has expired, there's a signature that's not valid, doesn't come from the correct certificate, blah, blah, blah. So the ROA is invalid, or everything works, everything matches, so the ROA can be valid. If it's valid, in this case, I checked the ROAs and then I move into the BGP validation. In the BGP validation, I take all the ROAs that are valid and I see if they match what I see in BGP. So if I have a ROA that says AS3333 should be announcing this network with the correct max length, everything's fine. So the network, the announcement at that point is RPKI valid. Otherwise, if it doesn't match because there's a mismatch in the autonomous system or in the network size, then the announcement becomes invalid, and then I should be dropping them. Then you see there's a whole part about unknowns. The BGP validation cannot happen if I don't have a ROA for a certain prefix. So in this case, the networks will have a valid an RPKI state, RPKI BGP state of unknown. This is where the vast majority of BGP networks are now. They are unknown at the moment. But we're working all together towards making so that most of them will become valid. What software can I use for validator? I have RIPE-NCC validator. That's the oldest one out there, but also the one that's less recommended at the moment because other software has picked up where the RIPE-NCC validator led the way. And the validator is written in Java, so it's a big software that's a bit slow and requires a lot of resources, but also because RIPE-NCC decided that at the end of the year, they will stop supporting it. So if you are looking into implementing RPKI, I would look into using the NLNet Labs, the Routinator, Octo-RPKI from Cloudflare, Fort from NIC Mexico, or even better, the OpenBSD RPKI client, which is integrated into the operating system. Now, how does this work? I have 3 examples, and one of them is actually a demo. So we'll go through a demo, and we're heading towards the end of the talk here. So in Cisco, I have I configured my RPKI server with the validator by suggesting BGP RPKI server, put the IP address, the port. Note that those ports are 2 different ports. This is a configuration that we used in a lab where we used to configure 2 validators on the same host for simplicity, and they operate on 2 different ports. And then you create a route map where you say accept, permit 10, so you match everything that's RPKI valid. So you ask the router to say, if it's valid, accept it. If it's the local preference is 100, fine. Accept something that's also not found and set the local preference to 80, so less preferred than whatever is valid. And then as you can see, there is no part where we say in this route map, do anything about invalids, match RPKI invalid, because we don't want to accept them. So we just say, don't do anything, just discard them. So we want to leave everything that doesn't match, every BGP announcement that doesn't match what's found in RPKI, we want to leave it out. And then we put the route map in the BGP sessions that we have with our transits. So in this case, we have 2 transits, IPv4 and IPv6, and we set we add the route map, and then we have to reload the BGP session to make sure the process reevaluates everything with RPKI in mind. This is with Juniper. Juniper is relatively simple as well. You set up the RPKI validator, you set up a session with a local address and the remote address over the correct port. And then you also set up a statement where you say if they are valid, if the RPKI validation comes up as valid, then to do this, the local preference is set to 110. And otherwise, if the term is invalid, just In this case, I'm accepting it as an example with a lower local preference, but we are also tagging them with a specific community, and we could just change it later on after we've verified that everything's fine. We could change everything to be discard. And then unknown, we accept everything as well as unknown, and we tag with a specific community. Now, for Bird, which is the routing software that I run here at home, I have a demo. So I actually am going to spend a couple of minutes configuring route object validation on Bird on my system here. And now it's always a bit, there it is. Okay, let me go back to sharing SSH. Though we move to this. This is one of the, this is a router I have, and if I do show protocols, you see that I have one that's already configured, that's Routinator. Routinator is my validator, which is already configured. The session is established since the last day of 2020. And what this is doing is I have a running validator. It has loaded into two tables that are called R4 and R6, all the ROAs. And then I have these BGP sessions, these four that are IPv4 and IPv6 for two transits this router has. This actually is the router that's giving me transit to the world at the moment. And these other sessions are over an internet exchange to other operators. Now, what I have here, this is the bird.conf. I have my routinator, as you can see. For IPv4, the ROAs go into a table called R4, and for IPv6, they go into a table called R6. The routinator is running at this IP address on port 3323, and everything's fine. But now I need to enable RPKI validation. So I have filters that I've set for my networks. These are the outgoing filters. Now I need to make sure I'm checking the incoming filters. I will gliss over OSPF. And here we go. Here we have filters for transit out over V6, transit out over V4, and CHIX, that's the Internet Exchange I'm connected to for V6 and V4. Now I need to add, and I've prepared them, I need to add two functions here. I'm copying them, copy and pasting them because I've prepared them on a side. So what I'm doing here is I want to have a function that tells me if the ROA, if the network is RPKI valid or invalid. And in this case, I'm checking for the invalids. So I have a function that runs another function that says that is the ROA check over route R4. That's the network. Sorry, the network, the routing table where I have the ROAs, the network that I'm providing, and the BGP path. I take the last path non-aggregated. And I check if it's an invalid. If it is, then I have to discard it. And I have V4, and I also have V6. In this case, I'm going to paste it in here as well. So I've prepared these two functions. Now, what I need to do is I need to go into my transit configuration, which I have simplified these this afternoon. Okay, so I need to go down and go into, let's say, Open Factory. So here I have an import all filter, which I had simplified today. Am I still on? Because I see, yeah, I think so. Yeah, see Peter. Okay, and I have to change it. So at this point, I do an import filter. Then I open it. Then I or close it as well. And then in here, I do, this is the v4 session. So I do just accept. If RPKI is invalid, then reject. Otherwise, accept. Voila. So on this session, I'm going to do RPKI check, and then let me enable it over IPv6 as well. Import filter. And I do the same. And I do v6. Do accept. And then I close this and I do voila. Okay, so now what I need to do is, well, I save the file. I go back to my bird prompt and I do a configure. So this reloads my configuration. There's no error, nothing. So I can do a show route filtered count to see where things have been filtered, and there's nothing. So why not? Because basically nothing has been refreshed. So I can do a reload in for Open Factory v4 and Open Factory v6. So in this case, we should be seeing something coming in soon. Strange. That's interesting, because then I did both v4 and v6 there. I configured it. Okay. Let's do this. Let's finish the slides, and then I'll go back to this while also we answer questions. So let me actually share the presentation now. Back. And say, where do we go from here? So now we are looking at the origin of the BGP session, of the BGP announcements, but then we need more building blocks. We need BGP sec, and we have other things that are being worked on. There's ASPA and ASCONs. What is BGP sec? BGP sec was created as a system to protect against path redirection attacks. So I want to have a system, an external system that says, well, I want to verify that that the path to a certain other network is exactly the one that's supposed to be. And for that, you would use the same systems you have in RPKI. So you would use the certificates to sign every BGP path. Now, the problem is, in BGP-SAC, if I receive a new BGP announcement, I would have to verify every single, so I would have to do a verification of the chain of trust for a signature in the AS path for every single addition into the AS path. So this turns into millions and millions of verifications I would have to do, especially when I run the full routing table, especially. So BGP-SAC exists in RFCs, but there's no implementation at the moment because it would require too much processing power from routers, so it's not implemented. But there are other ways we can do the same. ASPA, which is a draft, is a system where instead a network would announce who their upstreams are. So in this case, you would look into the ASPA objects, which would be also stored in RPKI and validated, and you would be using them to build a representation of how the AS path should be in real life, and then you can validate against that when you receive a BGP announcement. AS cones instead are the look the other way around and say who the customers of a network are. So if you think about AS sets, AS cones are the representation of AS sets in RPKI with a little bit, with some enhancements. Actually, I am the proposer of AS cones, and if you maybe one day want, we can have another session where I explain to you why we would need it and how it works in more details. And then you can do an origin validation check. If you open this website, this URL, the system checks if the network you are behind applies origin validation. So if it does RPKI checks. How? Basically by trying to open two objects from your browser, one that is on a network that has a valid RPKI status, and another one that has an invalid RPKI status. If you can reach both, it means the network you're on doesn't do origin validation. If instead you cannot reach the object that's behind the invalid network, it means you are discarding that BGP announcement, and then that's fine, you're protected. Now, wrapping it up, we have tutorials for MANRS. If you go to manrs.org/tutorials, there are some trainings that are about to begin. And also we have a hands-on lab that actually runs behind the router that I just tried to configure in Zurich. And we have examples you can run, configurations you can run with Cisco, Juniper, and MikroTik. And you can use it as just a standalone lab to test configurations, or you can use it as a final exam. So feel free to approach me if you have any requests about that, and I can forward them to the team. And then what you can do is you can join MANRS. You can fill out the form with as much detail as possible on manrs.org. We might ask you for questions and request some tests, and then you can get more and more involved in the community. So there's a really vibrant community on Twitter. We have a blog where guests usually write articles about what they see happening in MANRS, maybe new networks that joined, new networks that have configured all the MANRS action, and they are reporting on how they did it. So you can also find a wealth of information over there. So now I'm open to questions. While we switch over to the questions, I will have a look at the router configuration, and I will tell you more in a moment. So far, thank you for listening. I don't know how many of you are still there if you got too bored, but I'll see you in a moment.
Right. Well, welcome to the Q&A session. The pad was filled up and it's become a little skinnier again. So there's actually only one question left there, which is, have you tried DN42, which is at dn42.eu/home?
I know them. So I know it's basically a sort of community where people run BGP in a sort of a private organization. I know them. I haven't tried them. I am lucky enough that I could have access to the the fibers that come into my house. So I run my own ASN from home, and I have a layer 2 that goes from home to a data center. So for that, I'm really, really lucky. So that they're really affordable as well. So
yeah, the second part was it's a simplified BGP playground via point-to-point VPNs, and would you recommend using it to practice BGP? So,
I would, yes. I would recommend it.
Like safe playground to me.
That, and then if you, what you could also do is, some people really don't like them, but if you want to learn, there are also some virtual IXPs that are for free, and they really route your traffic. So again, if you would like to learn more about all this, feel free to write me. I published my email address earlier. You can find me on Telegram as well. And especially if you want to learn more about BGP peering and routing, I can point you to some interesting groups on Telegram where there are people in the same situation as you, people that are on DN42 or who run their own small ASN. And I could also help you with understanding the basics, configuring the basic routing, basic BGP announcements. I'm really usually happy about doing all this, if possible.
That's good. While we're talking, another question came up. What about core then, which is at GitHub? Core, have you heard
I
of?
don't know. That is the first time I hear about. But again, I'm happy to check all the pointers and see.
I guess I can just. Do you have the pad open, or should I point? I can just copy across.
Check a URL if you have it.
Yeah, it's coming up.
I would be more than happy to check. So this looks more like an emulator here, or okay, I see that. No, I haven't tried it, and I actually haven't heard about it either. But if you want to play with some network devices, I suggest looking at CRPD. That is from Juniper. And that is you can download it for free from Juniper. You have to register. That is basically you take a Juniper router, they removed the forwarding plane. So there's only there's the CLI, there's the routing plane, but not the forwarding one. And it runs in a container. So I have set it up. I finally made it this morning. So I actually wanted initially to show also configurations on Juniper being done live, but I ended up not making it on time. But CRPD can be also very, very interesting from the perspective of taking a normal Linux router, running Docker in host network mode, run CRPD on top of it, and use it to do all the configurations. It can also set your routing table, and then you use the normal Linux facilities to forward packets. But the CRPD is for free, so if you want, you can give it a try pretty easily. And again, if you want other pointers, feel free to email me about them.
Nice question came up is, do you have a blog or website?
I do. I'm still in the process of course, you know, it's an ever-growing task of keeping it updated. But if you check my surname, so that's stucky.ch, or you can find some other information on as58280.net. And that is the website I have for my own AS number.
Right. And then the next question would CRPD as a URL. I think you should probably be able to confirm or otherwise. Hang on, I'll just.
Yep. Let me see.
Was pasting here.
Yes, that is.
Yeah, that looks correct to me as well.
That looks correct. I'm not a Juniper expert, but I think that's the product you're looking for, and you can download it for free. You have to register. It's not open to everyone. They just want to see who you are. After all, Juniper is a commercial entity, and they define their own rules.
They're FreeBSD based, aren't they? Or
part of it is. Although now I know they are moving to Linux. So
right.
Most of it is FreeBSD, yes. So you still see something, but the reason it's containerized now, the way it is containerized now, it's and runs on Docker, it's basically Linux now, unfortunately. I mean, I don't really have anything against Linux. It's just that FreeBSD, me and Peter, if possible, we prefer BSD in general.
That's true. Yeah. Looks like there were no more questions coming up. You were thinking, have you gotten anything done with the demo thing?
I was checking the configuration again, and I don't see anything wrong. So it used to work until this morning. So I just basically removed the configs and added them and re-added them now. So I will need to check them again because maybe I forgot something along the way. But yeah, this is how it should be done. So this is a good opportunity to write something on the blog again to say, okay, I tried this doing it live during a presentation. It didn't work. So here's how you actually do it. So
yeah, at least you're still online, so it can't have been all bad.
Well, yeah. To be honest, I mean, I could kick off some. I actually have two other transits at home. I usually prefer these, which are from the data center. But I also have two direct transits at home. So I could actually knock both transits off that side and still be online. That's actually...
Here's another question. Is there a debug tool for this? I'm not sure which one they're referring.
Debug tool for... Can you specify for what you mean? Because there are many tools to check... So
MANRS looks like.
Oh, a MANRS debug tool. No, because you have specific tools for the different actions. So for RPKI, you have you have the how's it called? I discussed it this morning. The
yeah, I think it was referring to for Bird.
Oh, for Bird. Well, you have you're speaking an open protocol. So, and you would see what the other networks see on the other side. So for this, you would use what's called a looking glass. That's a software you run inside someone else's network. That's this other network puts it for you to use, and you run show commands on other networks routers. so you see what they see from their perspective. So use a looking glass. Then there's the tool I was looking for is IRR Explorer. And I'm gonna write I wrote it in the chat to Peter. Maybe Peter can broadcast it to everyone else. And it's
IRR Explorer. Okay.
Yes, it's a web-based tool from NUUG, from the Dutch Network Operators Group, where you can see how your objects are in the internet routing registries, and it checks several of them. So it gives you an idea of what you should be configuring, what's configured, if anything doesn't match what's in BGP. And it's a tool that's really, really useful. And then you have, still from NLNOG, there's the NLNOG ring that I'm sending also this as in the chat to Peter. The NLNOG ring is also a distributed tool that also gives you viewpoints from different network operators. So if you run an NLNOG ring leaf, basically an instance, then you get access to the NLNOG ring, and you can run debug tools on the other systems across the whole ring system. So trace routes, pings, MTRs, and so on. And then you have the biggest debugging tool for everything here is MTR, which is really useful in many cases. And you find it on every operating system.
And while we were talking there, another question turned up. Would it be possible to enforce security on other automated systems, possibly autonomous systems? What's the take on that?
How do you do that? It's because that is the problem MANRS has been having for a while, where you can run some checks. There is something you can verify, but something else you cannot. To give you an example, I used to work for RIPE-NCC, and RIPE-NCC used to run the RIPE Atlas, well, still runs the RIPE Atlas system. RIPE Atlas is a very good debug tool, and then you could run tests from other networks, from little probes in other networks. Now, there is one test that everyone has always asked for, and that would be the RPF check. See if RPF is enabled in someone else's network. Now, what is the problem with running such a test is that you have someone hosting a probe in their house, their office, and they're connected to someone else's network. And then you test if this person, this connectivity they have at home or in their office, would work with packets that are supposed to be spoofed. Now, you might get them in trouble. So there are some tests you cannot really do, and you have to trust the network operator that says, yes, I have implemented it, or no, I haven't. And that's the problem you face. So there's also a problem for MANRS where we can ask the network operators to run some tests at one point in time, but then their configuration might change. And then these are tests that cannot be automated. And then you see that in a couple of cases, we've had some route leaks or some other issues that happened to a network operator that was supposed to have put measures in place to avoid that. And then the question is, did you only set them up at a certain point to join MANRS and have your name on the list? Or do you keep the configuration in your systems? So this is a problem that MANRS is facing right now, and it is figuring out on a continuous basis if network operators keep the configuration as it is or not. And that's a challenge. And in the meantime, I realized what I forgot from the configuration on the router. So While Peter tells me the next question, I can.
Might be interesting to see just what that was.
Yeah, it's.
Before
I
you start.
forgot to tell Bird to actually keep the configuration, keep the filtered routes. So if I now do a, let me see, do a configure. Then that goes somewhere else. Goes in here. Yes, so now if I do it, that's for V6. You're still not coming. No, then it was not that.
All right.
Anyway, I'll figure it out later because I check it against the configs I have in Git.
Yeah, it sounds like there might be a blog post brewing there.
Yeah.
But...
Yeah.
Right. No further questions as far as I can tell. Maybe we should announce a countdown for them to actually click them in here. Or did you have something else on your mind yourself?
Am I thinking about something? Oh, tomorrow, tomorrow there is an interesting talk by Juniper. If you want to, I'll send the link to Peter in a moment. Once I open my calendar, you can register, and that's about. So tomorrow it's at 6 our time, 6 p.m. and it's about spine and leaf physical topologies in networks. So I'll send.
I can probably forward that to the mailing list at least.
Yeah. Okay. And anything else? I would say if you're interested in networks. The RIPE meeting that's coming up in May is going to be free and it's online. So that's a chance to participate there.
Worth looking into that.
Yes. So that's basically it. So I can't.
Oh, somebody's typing.
Oh, good.
Does it use IRC? You're on the.
I used to be. I used to be on, let me check. So I do have my entry still configured. But yeah, I used to be on IRC, and my nickname is my surname. So that's easy to find.
Right.
Actually, let me install IRC as I'm here so that I get to log in again. So I kept my configs. It's just that I haven't logged in a bit.
Which IRC client is the question?
IRC. This one. IRSSI.
IRSSI. Oh, yeah, well, that's a familiar one.
Yep. I'm on EFNet, on, well, Intercom is another one, but so there you go. So I'm on EFNet, Freenode, well, and other places. So I guess this is, okay, so I joined the channel now.
Right.
Here we go.
Okay. I guess there will be some more activity over on IRC then.
That's perfect.
So yeah, so I guess time has come to say thank you very much for sharing this time with us, Max. It's been I think a very useful session for a number of us. So
I was happy to be here, and I'm always happy to join if there are stories you would like to learn.
okay, thanks to everybody who joined in, and special thanks to Max for turning up the talk. Thank you.
Thank you.